Hey everybody, we're going to go ahead and get started on our fourth standard, which is to determine the solution set for logarithmic and exponential equations. This is actually one of the few chapters that we won't be working with inequalities, not because you can't use inequalities, but because it's really less common for the need of an inequality in a logarithmic or an exponential application. So because they're not used very often, we're going to stick to equations. And this video and video 10.4.2 are going to really address solving with no technology at all. So this is going to be just kind of exploring what we see to get an outcome. And it's going to exercise your mathematical brain. So you got to be engaged and ready to go. There are technology methods, but they won't be always available to us, so we're going to want to be sure we understand what we're looking at. Let's get started and you'll see what I mean. So here what we're going to do is examine the relationship of the two sides. So we want to kind of think of when I see a 2, for number 1, when I see a 2 and I see a 32, is there any correlation? Can I go from 2 to 32 using exponents? Okay, so for this, I might think, well, 2 to the first is 2, and 2 squared is 4, and 2 cubed is 8, and 2 to the fourth is 16. So 2 to the fifth is 32, so x equals 5. And you may not have had to go through all of that to get there, but this is one method. And what I came up with is that the only value that takes me from 2 to a power into 32 is x equals 5. Let's see how we can relate that to the second example. How are 3 and 81 related? Well, I know that if I take 3 and I raise it to the fourth power, I get 81. But this is 1 over 81, so I have to consider the fact that it got flipped, which means that x isn't 4, x is negative 4. That flipped it over and made it 1 over 81. Very similar is this one, where I have 1/5 to the power of x goes to 125. But I'm going to be considering how is a 5 related to 125. And I know that 5 cubed equals 125. But this took it from a 1/5 to a 125. So x doesn't equal 3, x equals negative 3. Now I put an asterisk next to this one, not because it's going to be treated any different, because I am still going to compare how do we go from 2 to 8, but I have this exponent that's no longer just the x. So here I'm saying, well, I know that 2 cubed equals 8. So that means that this exponent must equal 3. So I kind of have to set up a second equation, and it may be more complicated than this one, but it is a second equation that allows me to solve for x rather than just solve for the position of the exponent. So in this case, x equals negative 2. And let me take you back. That doesn't mean that 2 to the power of negative 2 equals 8. It means that when I substitute in a negative 2, it satisfies this equation. Let's look at a different approach. This one is going to have me using the power property of exponents to obtain the same base on both sides. So that's our goal, is to get the same base. So I know that 2 and 8 can be written using a base of 2. 2 is written as 2 to the x plus 4 power, but using the power property, I can write this as 2 cubed to the x minus 6 power. So 8 just got transformed to a base of 2. The reason I did this was because now I can say that if I have 2 to the x plus 4, and using the power property, I have 2 to the 3x minus 18, well, 2 to 1 power, let's just say 2 to the power of a, and 2 to the power of b, well, then logically, and hopefully you see this, is that a must equal b. So I go back up to this line and I say, well, 2 to this power equals 2 to that power. Those powers must be equivalent and we can solve. This will leave me with x equals 11. And you can verify by putting it on both sides that 2 to the 15th power, when you substitute in 11, and 8 to the 5th power will have the same value. You can check those in the calculator if you'd like to verify. Using a similar technique, we're going to change these both to the same base, but this time I have to transform a 25 and a 1/5 to have the same base. So I do need to consider the relationship between 25 and 1/5. And the relationship between 25 and 1/5 is that they both could have a base of 5. On the left side, I'm going to make this 5 squared to the power of x minus 2. And on the right side, I'm going to make it 5 to the negative 1 power to the power of x. I don't need that many parentheses, but there they are. Well, using the power property, that's what we're using here, the power property, I have 5 to the 2x minus 4 equals 5 to the negative x power. What does that mean? It means that 2x minus 4 must equal negative x. So let's solve. Negative 4 equals negative 3x, so x equals 4/3. Okay, we've got one more technique. Actually, it's two different techniques, but they look very different from each other, so we're going to give these two other a try. These are less common, but they're something we need to know how to do. On the left-hand side, number 1, we're going to be using radicals to solve this. That is, I'm going to write the left-hand side as b cubed, b to the 4th, I apologize, and that is the cube root. Now the reason I'm choosing this method is because now I'm going to, let's see, I can also write this, I'm going to take it one more step. I can write this as the cube root of b to the 4th power. Well, since it's being raised to the 4th power, I can take a 4th root of the other side. That is, I can take this and raise it to the 1/4 power, and I have the cube root of b on the other side. So I'm undoing the exponent by taking the reciprocal exponent. Well, the 1/4 is actually going to leave me with plus or minus 3. It's an even power, so I do get positive and negative because it's an even power, so you need to make a note of that. And now this equals the cube root of b. Well, how do I get rid of a cube root? I cube both sides. That means 3 cubed and it means negative 3 cubed, which produces two results, 27 and negative 27. So this actually has two different solutions. Since it's an odd power, an odd root, having both a plus or minus inside is okay. And that's really important to consider, that if this was an even root, I could not put back in a negative. Okay, you can't put a negative into an even root. However, positives and negatives come out when you take an even root. So we can discuss that more in the details and the differences. But last example. This is actually one where we're going to use the idea of the same bases again, but it had this radical. So if I write this as 3 to the 1/2 power, because a square root really represents a 1/2 power, now that's to the x minus 1. I'm going to write this as 3 squared to the power of x. So I'm still using the same base, but this introduced a radical, so I wanted to remind us that we can do that. Here I'm going to have 3 to the 1/2 x minus 1/2 equals 3 to the 2x. Once again, I have 1/2 x minus 1/2 equals 2x. So if I start combining like terms, I end up with negative 1/2 equals 3/2, that's 1.5 x. And if you were to multiply by the reciprocal, I'd have 2/3 times negative 1/2, which should result in x equaling negative 1/3. And that's our final example.